What is the coefficient of alpha to the power of 3 in the expansion of alpha to the power of 3 over 2 minus 1 all to the power of 15? Immediately, I think the first thing you should start thinking about is how to deal with this thing. As I've instructed earlier and before, you may proceed by multiplying this expression by itself 15 times, but that is not something I would recommend. Instead, we can use a very useful tool, which is the binomial theorem. And it says that if we have x and y to some power, n, and this n has to be an integer, then we can write it as follows. So x to the n minus k, y to the k, and n choose k as the combination, the number of ways you can choose k things out of n things. And of course, there's the sum. So let's not forget the sum. That is there, and we would like to make progress now. Perhaps you would like to pause the video and think about how we can make progress and perhaps combine this fact with that fact. From my side, I will proceed by finding the right values for x, y, and n. First off, I'll choose x to be equal to minus 1. You could also choose x to be alpha to the 3 over 2. It's not really a big issue. But the reason I can choose minus 1 is because, minus 1 is simply adding a negative number, right? And what we have here is an addition formula. So it shouldn't be too difficult to maneuver it, which is why we write x is equal to minus 1. And y, I will take to be the remaining term, which is alpha to the 3 over 2. And my value for n will actually be 15, because it's the value on the outside. So this should give me the same expression, but rather with the values which will be substituted. So the first thing I'll do, I'll replace the n's with the 15s. Second thing is I'll remove the y and I'll put alpha to the 3 over 2. Alpha to the 3 over 2. Then I raise this thing to the power of k. So that is very important. Perhaps this could be simplified. Yes, I can hear you. And x is minus 1. So unfortunately, we cannot completely rule out this minus 1. If it were a 1, then it is fine. But since it is a minus 1, then it will give us one of two values. So it will give us 1 if 15 minus k is an odd number. Sorry, is an even number. And it will give us minus 1 if 15 minus k is an odd number. And I think this is not too difficult to see. Now, I've been listening, and indeed we could simplify this expression. So if you're raising alpha to something and then to another thing, you could effectively and very simply multiply the two exponents by each other. We do this, and now we've made considerable progress. We're very much on our way to find the final solution. But we still need to ask one specific question, and that is, if we are looking to find the coefficient of alpha to the third, then we need to ask ourselves the following question. What k gives us alpha to the third? And the answer here is to, well, it's not straightforward. It could be, but we would like to proceed systematically. So the idea here is to equate the part of the expression, which includes the alpha, to the alpha which you would like to have. From there, I think it becomes obvious. You would like to find, k times 3 over 2 is equal to 3. Then it is quite probable that k should be equal to 2. So that is the second question you asked. So the first question, or the first step you could do is you could utilize the binomial theorem. The second step is to ask this very key question. Once this is done, you are very much ready, because the expression, the term that we're talking about, is precisely this one. But instead of k, we'll put 2, as we've already witnessed. Maybe I'll emphasize that this is the value of k which we found by doing this. 15 minus 2, and then 3 over 2 times 2. We know that this will give us 3. 15 minus 2 is 13. And so if you raise minus 1 to an odd number, it gives you a minus 1. And from there you can say that the coefficient that we're looking for, and this is naive notation, you could say, for what I would like to express here, coefficient of alpha to the third is simply, it's not 15 choose 2, but it's minus 15 choose 2. So minus of 15 choose 2. Minus of. So because this, I don't think there's such an object. It doesn't make sense. It doesn't make sense in the sense that it's not defined. To be very precise. So you have this. You could also have the alternative, which is minus. So minus of 15 choose 13, and this is also a correct answer. Now you should by now already know that these two answers are equivalent, because in a sense, if you're choosing 2 items out of 15, it is the same thing as excluding or not choosing 13 items out of 15. Now, if you would like to check, for example, or redo this exercise, you could try to do it with y is equal to minus 1 and x is equal to alpha to the 3 over 2. You'll get the same answer. You'll probably get this one directly, and you won't find it in the choices. So then you have to adapt the answer. You don't have to do it all over again, but you have to adapt in the sense that you make this link between the two combinations. So this is one way, for example, you could re-practice this question. Otherwise, you could proceed by expanding and multiplying this same expression by itself 15 times, which again, I'm not going to be there to witness.